a numerical example by using Lagrangian multiplier method. The numerical example is given mean z is equal to 2x1 square minus 24x1 plus 2x2 square minus 8x2 plus 2x3 square minus 12x3 plus 20 subject to the constraint x1 plus x2 plus x3 is equal to 11 and x1, x2, x3 greater or equal to 0. So we're gonna start the solution procedure. So according to the procedure discussed in the previous video of operation research, we will proceed to solve the numerical question. So first of all, let g1x is equal to x1 plus x2 plus x3 minus 11 is equal to 0. Then we have to form the Lagrangian function, and thus the Lagrangian function is Lx1 x2 x3 lambda 1 is equal to 2x1 square minus 24x1 plus 2x2 square minus 8x2 plus 2x3 square minus 12x3 plus 200 is plus 20 minus lambda 1 into x1 plus x2 plus x3 minus 11. Okay, this is the Lagrangian function. So now using the necessary condition for the Lagrangian multiplier method, we have to find the extreme point, and then using the sufficient condition, and we have to check the extreme point is either a minimum point or a maximum point. So let's check it first. So first we have to using the necessary condition, we will find the extreme value or extreme point in this case. So what is the necessary condition? The necessary condition is del L del xi is equal to 0 and del L del lambda I is equal to lambda j is equal to 0. Here I is equal to 1 and 2 and 3, because there are 3 variables x1, x2 and x3, and j is equal to 1 because there is one constraint. So we have to partially differentiate the Lagrangian function with respect to x1, first x1, then x2, then x3, and then lambda 1, and equal to all the and put all the equation equal to 0. And this after solving this 4 equation, we will get the extreme point x1 star, x2 star, x3 star, and lambda 1 star. Four x1 minus 24 minus lambda 1 is equal to 0. From this we can get x1 is equal to lambda 1 plus 24 by 4. Again from del x2 is equal to 0 gives that will gives if 4x2 minus 8 minus lambda 1 is equal to 0. This will give x2 is equal to lambda 1 plus 8 by 4. Okay, again del x3 is equal to 0 implies 4x3 minus 12 minus lambda 1 is equal to 0. That will give x3 is equal to lambda 1 plus 12 by 4. Okay, next another condition, del lambda 1 is equal to 0 gives the given constant, that is x1 plus x2 plus x3 is equal to 11. After putting in all the values of x1, x2 and x3 in this equation, we will get the value of lambda 1, and using this value of lambda 1 we will easily get the value of x1, x2 and x3. Lambda 1 plus 24 by 4 plus lambda 1 plus 8 by 4 plus lambda 1 plus 12 by 4 is equal to 11, and so this will give lambda 1 plus 24 lambda 1 plus 8 lambda 1 plus 12 is equal to 44, and or 3 lambda 1 is equal to 0 or lambda 1 is equal to 0. And using this value of lambda 1, this value of lambda 1 we get x1 will be 6, x2 will be 2 and x3 will be 3. Okay, then what is the extreme value? The extreme value is 6, 2, 3. 6, 2, 3 is the extreme point. So now we have to check whether this extreme value is the minimum or maximum using the sufficient condition of the method. So for the sufficient condition we have to form the Hessian matrix. It's a border Hessian matrix at this point 6, 2, 3. In earlier video I am discussed that HB is equal to 0 P transpose and Q, and how will we get P and Q? We will get Q by multiplying by the partial differentiating in del L del x1 and first by x1, then x2, then we will get the first row of q. After that then partially differentiate del L del x2 respectively by x1, x2 and up to xn. Then we will get the second row of the capital Q, and similarly del L del xn and by del x partial differentiated by the del x1 then x2 then xn, we will get the nth row of the Q. And how we will get that matrix P will be get by partially differentiating the constant and respectively by x1, x2 and up to xn. Okay, and since there is three variables, so the here Q will be 3 cross 3 matrix, and since there is only one constant, and therefore P will be a 1 cross 3 matrix. Okay, del G1 del x1 del G1 del x2 del G1 del x3. So we will get the matrix P as what is the value of G1, capital G1, and x1, x2, x1 plus x2 plus x3 minus 11. So after differentiating with respect to x1 we will get 1, and after differentiating with respect to x2 we will get again 1, and this also gives 1. Okay, therefore P the value of the P matrix is 1 1 1. We have to find the value of the P matrix or Q matrix at the point 6 2 3. Here all the partial derivative is a constant, so no need to put the point. Okay, whenever there is some variable as like x3 6x1 and plus 6 or 6x2 plus 4 and etc. we will have to put the values 6 to 3. Actually we have to put the value of the extreme point. Okay, and find the matrix P. Again we will calculate Q like this. x1 x2 x2 square x3 del x2, similarly del L del x3 del x1 del x3 del x2 del x3 and del L del 2L del x3 2. Okay, then what is the value event 4, that will give 0 0 4 0 0 0 4. So this is the Q matrix and this is the P matrix. Okay, so then we are ready to form border Hessian matrix HB. First of all, we will put P here, then the Q. What is the Q matrix? 0 0 0 4 0 0 0 4. Again, then P transpose 1 1 1. In the remaining portion, there will be 0. So what is the sufficient condition for the minimum extreme point, and what is the sufficient condition for the maximum extreme point? For the maximum extreme point, we have to start with the principal minor of order 2m plus 1 and the last n minus 1 and go up to the last n minus 1 principal minors, and we have to check the sign for the maximum point. The sign will be in alternative form, and starting with the sign minus 1 whole to the power m plus 1, and for the minimum point, the sufficient condition is we have to again start with the principal minor of order 2m plus 1 and going up to the last n minus m principal minors, and we have to check the sign of the principal minors, and for the minimum case the sign of the principal minor will be same as minus 1 whole to the power m. Okay, then here m is equal to 1, so we will start from the principal minor of order 3, and as this is a 4 cross 4 matrix, we will check the principal minor of 3 cross 3 order, and 1 is 4 cross 4 order. Okay, so first of all we have to check the principal minor of 3 cross 3 order. The principal minor 3 cross 3 order is 0 1 1 1 4 0 1 0 4, that is equal to minus 1 and to the power 8 minus 1 4 minus 0 minus plus 1 the 0 minus 4, that will be minus 4, and minus 4, that will be minus 8. This is less than 0. So again we will check the principal minor of order 4. 0 1 1 1 1 1 1 4 0 0 0 4 0 0 0 4. Okay, so minus, that value will be minus 1 0 0 1 4 0 1 0 4, and again this will remain plus 1 1 1 4 0 0 again 0 0 4 and plus 1 1 1 4 0 0 0 4 0, and this will gives the value the minus 16 and minus 16, that will give minus 48, that will give minus 48. So in both the cases, that is principal minor of order 3 and the principal minor of order 4, we will see that at both the cases the value is negative, and according to the sufficient condition for the minimum point, both for the principal minor order 3 and order 4, the value is same, both gives the same sign, and sign is similar to -1 to the power m, because here m is equal to 1, so both will give the negative value. Okay, so this satisfy the sufficient condition for the minimum extreme point. Therefore we can say that 6, 2, 3 will be the minimum point for the problem. Now we will get the minimum value of the objective function by putting in the point 6, 2, 3 in the giving objective function, and this is left for the viewers. Okay, now the time for the competition question. I will give a question, the answer will have to give within 24 hours in the comment section of this video. And the question is, solve the problem by using Lagrangian multiplier method this is the problem. You have to comment the answer within 24 hours. Okay, let's do it fast.